So, what if the apocalypse everyone's so worried about, a world with no ice, is actually our planet's normal state? Today, we're going to dig into that surprising truth, not as science fiction, but as maybe the single biggest design challenge humanity has ever had to face. Let's jump in. This is the big question, right? It's the one that hangs over our future. What really happens when every single glacier, every ice sheet, all the sea ice on the entire planet just melts away? It's a scenario that's going to completely redefine our world, and we really need to understand what it means. And here's the first big mind-bender. A world without any ice isn't some kind of planetary disaster, it's the norm. For a whopping 80% of its history with complex life, Earth was this lush, warm planet with absolutely no polar ice caps. The icy world we live in right now, that's the exception, not the rule. So if we want to figure out where we're headed, we've got to become detectives of the past. We're going to look back at Earth's super long ice-free history, because believe it or not, the clues to what's coming are buried deep in time. This timeline gives us two really crucial snapshots. First, you have the Eocene, which was basically a tropical, ice-free paradise. But the Pliocene? Now, that's the one that should really make you sit up and pay attention. It's the last time CO2 levels were where they are today, which makes it our most direct and, frankly, our most alarming preview of what could be coming next. All right, so let's bring it from the deep past right into the here and now. We're shifting from that slow geological time to what's happening as we speak. Because while an ice-free planet isn't a new thing, the speed at which it's happening today, that absolutely is. Seriously, if there's just one word you need to remember about the current situation, it's this one: accelerating. The planet used to change its climate over millions of years. We're doing it in just a few generations. It's really the difference between taking a slow walk and, well, falling off a cliff.
And look, this isn't just one study making some wild claim. We're talking about a rock-solid consensus from the world's top scientific bodies. The IPCC confirms this acceleration is real. Research from scientists like Binchliedler shows that ice sheets sitting in the ocean are incredibly vulnerable to warmer water, and places like the National Snow and Ice Data Center are literally tracking this decline in real time. The evidence? It's overwhelming.
This quote from the NSIDC just hits the nail on the head. It perfectly captures why this matters so much. Think about it. That bright white ice reflects the sun's heat right back into space. But when it melts, it uncovers the dark ocean, which just soaks that heat up. So losing sea ice isn't just a symptom of warming. It actually speeds the whole process up. It's like turning off the planet's AC on the hottest day of the year. So what happens when the melt keeps accelerating? Well, the consequences are honestly staggering. We're not just talking about hotter weather. We are talking about a future that will physically, literally rewrite the map of the world. Just look at this comparison. Our world, on the left, is built on the idea of stable, predictable coastlines. The world on the right? It's a world in flux. We'd see a great migration as whole populations are forced inland, and we'd have to completely rethink how we design our cities. And at the exact same time, new shipping routes would open up in the Arctic, totally redrawing the lines of global trade and power. Now, I know this all sounds pretty daunting, but this is the crucial pivot point. Instead of just seeing this as some unavoidable crisis, we can reframe it. We can look at it as a design challenge. Yeah, a massive one, but one that calls for planning, ingenuity, and adaptation. So what does this design challenge look like in practice? Well, it starts with 4 key actions. First, we need to begin a managed retreat, which means strategically moving our most critical infrastructure to higher ground. Second, we have to engineer a new kind of agriculture that can actually thrive in saltier conditions. Third, we can use AI to predict and warn us about major events, like the collapse of giant ice cliffs. And finally, we have to invest in a blue carbon economy, restoring natural defenses like mangrove forests. And just so we're all on the same page, let's quickly touch on that term, halophyte. It sounds complicated, but it's not. It's simply a plant that's adapted to grow in salty water. As salt water seeps into coastal farmland, developing crops from these kinds of plants is going to be absolutely fundamental for making sure we can still feed everyone in a high-water world. This brings us right to the core takeaway. An ice-free world is not the end of the world. The planet itself, it'll be fine. It will adapt. But it is the end of the world as we have built it. Our entire civilization, everything, rests on the assumption of stable coastlines, and that foundation is beginning to shift. So, to survive and thrive, our strategies for the future, our very way of thinking, needs to become as dynamic and as fluid as the rising oceans themselves. The real question this leaves us with is a simple one. Are we ready to adapt?